Okay, thank you for joining us again as we continue our work with vectors and in particular looking at applications of vectors. Uh, we've done a problem with kinematics. Now let's look at an exam style question where vectors play a key role. Okay, so in this particular problem we have a slope part of a hill which starts at sea level, right? So we can say, hey, that this little bottom part of my hill starts at sea level and it is described by my equation, right? So this hill, which starts at sea level, x plus y plus 5z equals 1, okay? The z coordinate represents the height above sea level, right? The flat ground at sea level that I put over here in blue, that's described by the equation z is equal to 0. And at the top of the hill, we have equation z is equal to 100, represents the flat top of the hill. And we have someone that walks directly from point P at the bottom of the hill to point Q at the top. Okay, so what do we ask? We want to show first that the line of intersection between the planes at the bottom of the hill, so we want to show that this line of intersection, right, has the equation r equals 0, 1, 0 plus lambda times 1, negative 1, 0. So how can we do that? So we know what the equation is. We need to figure out the work that would get us to that equation. Well, what do we know? Point P is on both planes, and we know that one plane has z is equal to 0. So if z is equal to 0, we know that x plus y must equal to 1. So that means that y must equal 1 minus x, right? X can just be my parameter, and z is 0. So my equation would thus be y equals the x value, the y value, the z value, plus my directionality. In the x direction, x is directly related to itself, y is related to negative x, and z is 0, right? It's not related, it's always 0, so it's never going to change, so not related to my parameter. So there I have my equation. Then, if I want to show that the angle at the bottom of the hill is given phi, if I look at this particular setup, it looks like what I have is an obtuse angle. It looks like I have an obtuse angle because I have pi minus an acute angle, and I know I have that the arc cosine of 5 over root 27 is acute because the numerator is positive. So let's say that I call that angle alpha, right, where that's going to be, we can tell, the inverse cosine, right, or the arc cosine of 5 over root 27. And this angle out here would be theta. So we want to show that alpha is indeed this inverse cosine of 5 over root 27. How can we do that? Well, the way that we can do that, remember, is that we need the angle between, right, we need the angle between 115 and 001, where 115 represents, right, the normal vector from x, y plus 5z is equal to 1, and over here 001 represents the normal vector from z equals 0. So how do we find the angle? Well, that's our dot product. Remember that the cosine of theta is going to be our dot product, 115 dotted with 001 all over the square root of 1 plus 1 plus 25 times the square root of 0 plus 0 plus 1. And 1 times 0, 1 times 0, 5 times 1, so that clearly gives us the 5 for the numerator, the root 27 in the denominator. But remember, because that's acute, that's going to be the cosine of alpha, and we know that theta is the complement to that, so therefore theta has to be pi minus, right, that inverse cosine of 5 over root 27, as what we were trying to show. Then, when the acute angle between flat ground and a hill is greater than 30 degrees, right, So if alpha is greater than 30 degrees, it can be very challenging for most people and may require using your hands for support, right? It can be very challenging for most people to walk up, right? So determine with reasoning if walking up this hill would be very challenging for most people. So in other words, is alpha greater than 30 degrees? Well, how can we figure out if alpha is greater than 30 degrees? So a little hint we can give you is consider comparing to the sine of 30 degrees. What do we know? The sine of 30 degrees is 1/2, right? We know that the cosine of alpha, is 5 over root 27. So therefore, we know that 1 minus 25 over 27 is going to be the sine squared of alpha, right? And that gives us 2 over 27. So therefore, we know that the sine of alpha is going to be the square root of 2 over 27. And we know that that means, that implies that alpha is less than 30 degrees because the square root of 2 over 27 is less than 1/2. So it's not a very difficult hill, right? So a little work with vectors, a little work on finding angles between, and being able to support our work to ensure that what we do makes sense and we can apply these vectors ideas in context. All right. We'll continue with some more problems. As you have questions, please ask. Thank you very much for your time.